In this video, we'll build colorful custom checkboxes in Java Swing, complete with shadows, highlights, and smooth check marks. Let's dive right in. Let's start by creating a new Java class called Fancy Checks. At the very top of the file, we'll import all the required packages. We need Java AWT for colors, graphics, and layout support. Next, Java Auth event for handling events like item selection. We'll also import Java Util and Java Util Stream collectors to easily manage and format our selected items list. And finally, Java X Swing for all the Swing components, and Java X Swing border empty border to give our layout some clean spacing. Now let's add a small helper method called wrapRow. This method takes a checkbox and places it inside a new panel. We're using a flow layout aligned to the left, with a little horizontal spacing of 8 pixels. The background is set to white, to match the rest of our UI. Finally, we add the checkbox to this row and return the panel. This keeps our layout clean and makes it easy to stack items vertically. Next, we create a helper method called selectedText. It takes a variable number of checkboxes as arguments. Inside, we use a stream over the array of boxes, filter only the ones that are currently selected, and map them to their label text. We then collect those names into a list. If the list is empty, we return the word none. Otherwise, we join all the names together with commas and return that as a single string. This makes it really easy to display which checkboxes are currently selected. Next, we'll create a static inner class called colorTickIcon, and it will implement the icon interface. This class is responsible for drawing our custom checkbox look. Inside our colorTickIcon class, let's define a few fields. We keep the color called fill, which stores the background color of the checkbox. Then a boolean called checked, which tells us if the icon should draw the white tick mark. We also define size as 28 pixels, which controls the overall width and height of the square. And finally, arc set to 8, to give the corners a nice rounded look. Now we add a constructor to the colorTickIcon class. It takes 2 parameters, the fill color and a boolean called checked. Inside, we assign these values to our fields. Next, we override the getIconWidth and getIconHeight methods. Both simply return the size value we defined earlier. This tells Swing how wide and tall our custom icon should be when it's displayed. Finally, we override the paintIcon method. This is where we do all the custom drawing for our checkbox. Swing gives us a graphics object, along with the component, and the X and Y position where the icon should be painted. Inside the paintIcon method, the first thing we do is create a new graphics 2D object from the original graphics. Then, we enable anti-aliasing by setting a rendering hint. This makes all of our shapes, the box and the check mark, look smooth and crisp instead of jagged. Next, we set the drawing color to a semi-transparent black. With this color, we fill a rounded rectangle slightly offset from the main square, shifted a few pixels to the right and down. Now we switch the color back to our fill color, the one passed into the icon. Using this color, we draw the main rounded square, positioned just inside the shadow. This becomes the colorful body of our custom checkbox. To give the box a glossy effect, we set the paint to a vertical gradient. It starts with a semi-transparent white at the top, and fades to fully transparent at the bottom. Then we draw another rounded rectangle over the body, using this gradient. The result is a subtle highlight that makes the checkbox look polished and modern. Next, we set the color to a very light, transparent black. With this, we draw a rounded rectangle around the box. This subtle outline adds contrast and definition, making the edges of our checkbox stand out more clearly against the background. Finally, we check if the box is marked as checked. If it is, we set a thicker stroke with rounded ends, and change the color to white. We then calculate a few base coordinates, and use two line segments to draw the classic tick mark across the square. This completes our custom checkbox, showing a clean white check when selected. And finally, we call dispose. This releases the graphics resources we created earlier, making sure we don't leave any extra objects hanging around. Now let's create a helper method called makeColorCheck. This method takes three arguments: a text label, a fill color, and a boolean to decide whether the checkbox should start out selected. Inside the method, we first create a new checkbox and pass in the label text. We then disable all the default painting, making it non-opaque, removing the focus ring, borders, and background fill. Next, we set the cursor to a hand pointer, so it feels more interactive when hovered. Now comes the important part: we attach our custom color tick icon. The unchecked state uses a new icon with a fill color but no tick. The selected state uses the same color but with the check mark drawn. We also provide matching rollover icons, so hovering works smoothly. After that, we position the text to the right of the icon, add a small 12-pixel gap, and finally set the initial selected state based on the parameter. At the end, we return this customized checkbox, ready to use. Now let's move on to the main method. This is where our program starts running. We use swing utilities invoke later to make sure the user interface is created safely on the swing event thread. First, we create a new JFrame and give it the title Fancy Checkboxes. Then, we set the default close operation to exit on close, so the program will shut down completely when the window is closed. Next, we create a root panel using a border layout to manage our components. We set its background color to white for a clean look, and then add an empty border with 16 pixels of padding on all sides. This gives the layout some breathing room and keeps the content from sticking to the edges of the window. Now we create another panel called List. We set its background to white so it matches the root panel. Then, we give it a box layout on the y-axis, which means all our checkboxes will be stacked vertically in a neat column. Next, we create a J label called Status. This will be used to show which checkboxes are currently selected. We also add an empty border at the top, giving it 12 pixels of spacing so it doesn't stick too close to the list of checkboxes. Now we create 4 colorful checkboxes using our MakeColor check method. The first one is labeled red, and we give it a bright red color to stand out. Next, we build a purple checkbox, with a rich, bold shade. Then we add a green checkbox, using a fresh and vibrant green tone. And finally, we create a blue checkbox, giving us a cool, calm option to complete the set. By passing true as the third argument, each checkbox starts in the selected state. This way, when the program first runs, all 4 colors are already checked and displayed in the status label. Next, we create an item listener called Update. Whenever any checkbox changes state, this listener updates the status label. It calls our selected text helper method, passing in red, purple, green, and blue, and then displays the result with the prefix selected. Now we attach the update listener to each checkbox. Red, purple, green, and blue all share the same listener, so whenever any one of them is checked or unchecked, the status label is refreshed automatically. This keeps our code simple and ensures all 4 checkboxes stay in sync with the status display. Next, we add all of our checkboxes into the vertical list panel. Each checkbox is wrapped inside a row for consistent alignment, and between them we insert a vertical strut of 10 pixels. This extra spacing makes the layout cleaner and ensures the checkboxes don't look cramped. One by one, we add red, purple, green, and blue, each with a little breathing room in between. Finally, we trigger the update listener once manually, by firing an item event on the red checkbox. This ensures the status label is initialized correctly when the program starts, showing the selected items right away without waiting for the user to click anything. Now we add our components into the root panel. The vertical list of checkboxes goes to the top, using the north position of the border layout. And the status label is placed at the bottom, in the south position. This keeps the checkboxes neatly stacked above, while the current selection is always visible below. Finally, we set the root panel as the content pane of our frame. We give the window a fixed size of 360 by 300 pixels. Then we center it on the screen with set location relative to null. And at the end, we call set visible, true, to display the fancy checkboxes window. Thanks so much for watching. I hope you enjoyed building these colorful custom checkboxes in Java Swing. Don't forget to like, share, and subscribe for more creative coding tutorials. Your support means a lot. See you in the next video.